Okay, so what are the networking devices? So whenever we discuss the requirements to form a network or create a network, so first one is NIC and network interface card. NIC is also a physical device. Either it is basically a chip and for a connectivity like a RJ5 connect RJ45 connectivity, or maybe it is a Wi-Fi connectivity kind of stuff. Either it is a separate LAN card is available, or it can be a onboard chip can be available. But it is a NIC, network interface card, for connecting a device to network. So we need a small interface, right? To connect it, either normally we use a cable connection, either coaxial type of connection, normally UTP, STP type of connections, or maybe fiber optical channels. For example, if you are in a servers or a storage devices or a high speed data transmission places, okay, storages places, we use a fiber optical channels, right? Um, these things, right? Like are wireless communications, wireless related communications. So we need a media. And we already discussed about our different protocols and OSA layers also. The way it is a network is created and connected and communicated by OSA layers, we explained that one. In that one, protocols also we explained. Okay, what are the protocols? For understand what is your request. What is your request? Are you asking for a web page, HTTP request? Are you asking a file download, FTP request, kind of stuff, right? So protocols and logical addressing like a IP addresses. So we already seen IP address, IPv4, IPv6, IPv4 class A, class B, class C, and class A 0 to 127 or 1 to 126, class B 192 to 220, 128 to 191, class C 192 to 223. Okay, and there is a default subnet mask for a class A is 255.0.0.0, class B 255 255.0.0, 255 255 255.0. So these are IP address related information, right? You two systems required to communicate each other, they should have a address. So what address? IP address. Okay, both should be configured IP address, both are in a logically same network. And how they will communicate, for example, if it is a ping communication, like you are sending a ping request, so it use a ping related protocol like a ICMP protocol. Okay, for example, there is a web server and a client, so HTTP protocol. If for example remote server and I'm accessing remote server from my PC using a RDP protocol, remote desktop protocol, or SSH protocol, or telnet protocol. I want to send a mail, SMTP protocol, right? So these are the protocols used to communicate. IP address to address. So without addressing, we can't communicate. So here is a middle one is devices, which makes a connection between these devices. What are the network involvement devices? Either it is a mobile phone, or it's a laptop, or a desktop, or a tablet, or maybe a either smart TV or smart LED. Okay, or maybe it is a printer, network printer, or Wi-Fi printer. So what are all these devices, including devices like a hub switch routers, firewalls, okay, or servers, storage devices. So all are devices only. So to connect these devices, we use either UTP, STP type of cables, or fiber optical cables, or wireless channels. We use it. Okay, for making all together connections, we need a basic central devices, or with a different purpose of devices are there. So what is these devices? Networking devices. What are the device, like you have a computer or a laptop or anything, you want to make form a network. So you are saying it is a network. There is must be a maintaining a connectivity, a centralized connectivity or a multi connectivity. So that is we require certain devices. So some devices names I've written. These are the important devices plus modem. Okay, these are the important devices in the networking devices. Means first is hub, switch, router. Three, hub, switch, router. Remember, guys, hub, switch, router. Hub is a layer 1 device, switch is a layer 2 device, router is a layer 3 device as per the OSA layers. Okay, hub, switch, router. The next one is modem. Next one is modem. Okay, so these are the important devices, but we will go to one by one. What is repeater or a hub? Hub and repeaters are the same, exactly say hub and repeaters are almost same because of hub act like a repeater. Hub is a look like this one, so if you want I can increase the size of the hub like this. Hub and switches by small hubs and small switches both are look like a same. Normally we can't guess how what is which one is hub or which one is switch also. Make sure that if something written on it, so it is a, like a networking hub or it is a hub, then we can able to identify. Sometimes we can't identify also. Hubs are cheaper. Hubs don't have more secure things in the hub inside. Non-intelligent device, because there is no intelligence, nothing is there, means there is a no specific calculations are not there. Hub receive a data from hub receives a data from PC and distributed to all other PCs. It's a broadcast type. Means you can see this one. This first PC sending a message. So then hub take it and send it to everyone because hub don't know which is the actual destination. Which is the actual destination. Okay, so that is the thing. It works with bits used for uses broadcast for a communication means I am a computer ABC. There is a computer. We have to draw again. And instead of drawing, it is yeah, shaping is also there. We look at here. This is the hub. Say device is hub, outer line. Sorry. Yeah, very good. Okay, so this is why it is hub. These are PCs, for example. Okay, why it is. Okay, and you know each hub like this. It is very difficult to create like this. Proxy. No, 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 no. This. This is like a, artwork without taking any class. It's something. Sometimes it is look like that one only. I'm doing for now. Well, I don't do this much of artwork. I try. I like paint, so then it is very easy. So I'm connecting a PC to here. Which topology it is, guys? If I connect like this, what kind of topology it is? Tell me what topology it is. Bus topology, a ring topology, or is it a mesh topology? I'm muted or what? Or it is disconnected. Normally, you guys will normally give people give response, right? Okay, it is like this. So a big waste of time it is. It is a hub, and these are all like a PCA, PCB kind of stuff. So I will write directly. Um, this is APC, BPC, C, D, F. Okay. So what happens here? Okay. Look at here. A want to send a packet to B. A is want to send a packet to B, like a pinging. So A is sending the packet. So A send packet to. So, okay. So A send a packet. So then first packet goes to the hub. Okay, packets go to the hub, and the packet now sent to the B, and same packet sent to the C, and same packet sent to the D. Same packet is sent to the E, and sent to the F also. So everybody get the packet. Everybody will get a same packet, and they will verify. They will verify like this: is this packet belongs to me or not? Okay, this is A to B communication. So first of all, I will go to a downside. D checks. Source is A, destination is B. This is source. This is destination address. D checks destination address. It is belongs to B, not belongs to me, not belongs to D. So what it is? It dropped the packet. It dropped the packet. Next, E checks whose packet it is. It is a D's packet. It will drop the packet. Okay. Same F drop the packet. C drop the packet. And B destination is a B's IP address, and it will verify it is belongs to me. It accepts the packet. It accepts the packet. Accepts the packet. So like that, it's an entire communication with the hub is like that only. That's a hub is called as a single broadcast domain and single collision domain. Hub act like a repeater. It repeats the signal. For example, 100 meters is a your cable's maximum supporting length. For example, what I done after 80 meters, after 80 meters, I put a hub. So then I can put another. I can extend I can send my signal for a little longer period of time. For example, I am configuring big LAN like an entire building or a CAN network, campus area network. So campus means buildings are little longer distance, right? So that much long distance, cable not supported. So what I have to do it? Put a hub or a switch or a repeaters. So then the signal will repeat. It not a boosting signal is not boosting. It is repeat the signal. So then it travels the signal for longer time. We should not boost the signal. We can repeat the signal. Okay, uses broadcast for communication. Bandwidth is shared. Okay, off duplex communication means when we are sending a packet, same time we will receive the packet also. Or a 2 3 packets will be received from different sources. Collisions are more collisions will occur. It is a layer 1 device as per the OS layer, used for small communication, used for LAN communication, used for small networks type like a 4 5 systems, no problem. Okay, number of collisions will occur, more number of collisions are high, so then data packet loss is also high. Data packet loss is also high. So repeater repeats the signal again, so then signal can send a long distance time. So this is the example of hub. Guys, this is a switch is an intelligent device. It understand MAC address. It understand MAC address and it creates MAC address table. Okay, as per the OS layer, it is a layer 2 device, which is data link layer, and only used for a LAN communication. Some people may ask a question, so what is layer 3 switch? Okay, so what is layer 3 switch? What is layer 3 switch? Guys, switch means layer 2 only, and of course there is a layer 3 switch is there, but switch means layer 2 only. What is layer 3? Layer 3 having some protocols, right? Network related protocols, routing and routed protocols. So router understand this routing and routed protocols. Okay, routing and router protocols. So whenever we are not this one, so we'll go to some other points. Here it is. L3 switches. L3 switch, okay, is available. Switch is layer 2, but what is this? Layer 3 switches. Layer 3 switches do routers function also, means routing part, mainly used at inter VLAN routing, VTP, okay, virtual VLAN trunking protocols, inter VLAN routing. So in that kind of concept, so we use LAN, L3 switches. Campus area networks. When you create a campus area network, it is we don't use WAN communication there. LAN communication only, but it is bigger communication. So that time we can use L3 switches. And routing function means inter network communication. Inter network communication. That is a router function. Okay, so this is our things, guys. So again, switches are like this. Switches supports small to medium to large networks. Okay, large number of devices we can able to connect it. Number of collisions are little lesser than hub, so lesser the packet data loss compared to hub. It operates in full duplex mode, and there is a different type of switches are there. Cut through switches, store and forward switches, like that switches are there. So switches function is MAC learning, MAC address learning, forwarding the packets. Switches basically don't understand IP addresses, guys. Switches don't understand IP addresses. Switches understand MAC addresses only for MAC address table creation. So these are the MAC address table creation, guys. So these are my PCs. Each PC having a MAC address and there is a IP address also. When they are communicating each other, so switch learns these MAC addresses from the PC communication only. Source MAC address, destination MAC address in the packet. So it will take it. So based on the source MAC address, it create like these are the switch port numbers: port 1, port 2, port 3, port 4, port 5, like that, and their MAC addresses will tabulate. Because of this tabulation, it is very easy to unicast the things. Again, switch basically act like a broadcast. For example, you are sending a message to A to B. So A PC send a message to switch, switch broadcast to everyone. Switch broadcast to everyone. So what happened? Everyone will get the packet. Only B accept the packet. Remaining will be drop the packet. So I'm telling same story as a hub only, right? But while it is communicating, switch understand or lens MAC address. The first port is connected to PCA and it note down the PCA MAC address. Like each port, when there are devices are communicating each other, that time it learn the MAC address of the devices and assign to the port numbers. So now, for example, I have a table. C want to communicate it to E. C is communicating to E. C send a message to E. Then what happen? C is sending to E. E is belongs to E. So E is belongs to port number 6. The message C to E directly go to E. So C to switch, switch to EPC directly it will go. So that's how it is. Initially it is broadcast, later it is multicast. Initially switch broadcast and later it is unicast. Okay, so lesser the collisions will occur, lesser the data loss possible, and we can put it for a small to medium and a large networks also we can connect it to these switches. Okay, guys, these are the switches. Hub and switches are used for LAN communication. Hub is for small networks. Switch is for a small, medium, large networks. Also, we can able to use it. Hub is a layer one device. Switch is layer two device. Used for LAN communications. Okay, switch can understand MAC address, learn the MAC address from the source PC, and assign to its switch port number. Switch port. Okay, lesson. So then, initially switch act like a broadcasting kind of stuff, like a hub. But later, once it is learn the MAC address and create a MAC table, it is do unicast. Okay, next one is bridges and switches, guys. Again, there is another column here. It is switch is a physical device which contains multiple connections like this. So number of multiple devices we can able to connect it to the switch. But bridge is not even any kind of physical device. It is if you take a server or a PC, you have a one or two or more NICs are there, and you can create a software between these NICs. Very less number of networks will make you communicate between that one. Okay, bypassing that one, local LAN, VPN, okay, that kind of stuff we can able to do it. So virtual bridges also available if you are using a virtual machines. Okay, like this. So bridge is software based, not hardware based. Very less ports means you have a PC computer with two or three NICs are there. So then it is also works like a bridge or a switch kind of stuff, but it is the functionality, connectivity, number of segments will be less. And another very important one is router. What is router? Is a very intelligent device. Okay, router is a very intelligent device. Okay, so it is a fixed bandwidth, works with the logical addressing like a IP address, IPX, and Apple talk kind of stuff. Like a IP address, it understand IPv4, IPv6 addressing also. Internetworking device. What is internetworking? Communication between different networks. Communication between different networks, logically different networks. So it is used. It connects to our more networks. It works for a LAN internally and works for a WAN externally also. Means we can connect from our network to outside network using a LAN connectivity as well as a WAN connectivity also. It is a layer 3 device which is network layer as per the OSA layer. What is router? Route means path. Router means it shows the path to reach the destination. Routers use routing table to know how to reach the destination. So here it is a different routing tables are created by static routing and dynamic routing. Static routing is manually you have to tell how to go. Simply like a Google paths, Google directions are there. It will tell you best path to reach the destination. You follow the path, you reach the faster way. Manual means you know the how to reach the destination. So you said go straight, take left, take straight again. So to take a U-turn and come back like that. So you create a path on yourself. That is a static routing. Dynamic routing will calculate different things like the bandwidth. Dynamic routings based on the bandwidth. Lesser stops. Lesser stops. Okay, Vishakhapatnam to Hyderabad. More stops are there, more time it will take. Lesser stops are there, less time it will take. There is a route with less stops. There is another route with more stops. So more stops will take time. Less stops, very less time. Bandwidth. Larger the bandwidth, faster the communication. Smaller the bandwidth, slower the communication. It does not mean always same, but it is always so also different one. Okay. Bandwidth. Delay, traffic delay is there, right? So traffic delays will occur, right? So it depends upon your distance between source and destination, depends upon the distance, depends upon the bandwidth, depends upon the delay, depends upon number of hops or stops mainly. Link status depends upon the link status. These dynamic routing protocols will tell you the best path to reach the destination. Examples are IGRP, Interior Gateway Routing Protocols, works within autonomous system. Within autonomous system, RIP version 2, EIGRP, OSPF. EGRP is a exterior gateway routing protocols. Exterior gateway protocols are routing protocols. Example is BGP, Border Gateway Protocol, and ISIS, Intermediate System. So these are the router related information. Guys, again, hub, switch, router. Hub switches are for LAN communication. Router is mainly for WAN communication purpose. Okay. Um, Router is a layer 3 uh, device which is belongs to network. It can understand IP address and routing protocols information. It will tell us how to reach the destination. It will make you to reach the destination. We use the trace rt command earlier. The trace rt command is showing what is the path you reach the destination. So the IP addresses it is showing on the screen is belongs to the routers in between your system to the destination. Okay, so that is the main part of your router. Again, switches understand MAC address, intelligent device, MAC address, layer 2 device, works for small, medium, and large LAN networks, connects multiple devices. right? Prepare a MAC address table kind of stuff. Hub is a layer 1 device, non-intelligent device. Okay, used for us better for a small networks, not large networks. Okay, better for a small networks, not large networks. Okay, bandwidth is shared and a lot of collisions and all kind of stuff. So small networks are better to use. It does not understand any MAC address or IP address. It just take the uh, packet and forward the packet to other ports, like a broadcast to every other port. So that is the three devices are I told. So yeah, this is we got directly a topology point. But here it is. We have to discuss about a modem also, guys. And after modem, we have to discuss about this modem. Modem means modulator and demodulator. So why this is big error? Letter. What is a modulator and demodulator, guys? Example: FM radio. Our voice signal is 20 to 20 kilohertz frequency. Voice is 20 to 20 kilohertz frequency. It is called a baseband. My voice baseband is 20 to 20 kilohertz frequency. So what I'm talking it is. So this frequency cannot reach up to certain distance, like a 1 kilometer, 2 kilometers. We cannot able to show it. We can use amplifiers to amplify the pitches. We are not amplifying frequencies. We are amplifying the pitch level. No coding, no decoding kind of stuff, right? In that one. So what we are doing, we are this signal we are adding to some high frequency, for example 104 megahertz frequency. I'm talking in a FM radio. Okay, so when you tune your radio to 104 megahertz frequency, because of radio is India operating speed is 88 to 108, operating frequency is 88 to 108. So 108, 88 between you are getting things. If you go to other countries, maybe different frequencies, but FM frequencies 88 to 108 only. Okay, so your voice signal is 20 to 20 kilohertz. So 104 megahertz frequency mix with your signal and it will send. So what I have done, at a receiving side, I have put a 104 megahertz frequency, 104 megahertz frequency. So I filtered it and get my original frequency, personal voice. I will get it. So this is called a frequency modulation. So the left side means this side I modulate the signal, this side I demodulate the signal. Just for understanding, I'm telling this thing how FM is works. Understand? Okay, your voice is mixed with a high frequency and broadcast to everyone. So you have a FM radio, you tune to 108, 104. Okay, so then you filter 104 main carrier signal and you get this one. What is the purpose of this one? Somewhere in the city we have a FM radio, but you can able to hear once you tune to the FM, you can able to hear the information in the FM radio, right? So this is called a modulation and demodulation. We modulate and send, we demodulate and we receive and demodulate and we'll get that information. Similarly, the modem is modulate or digital signal to analog signal. Okay. So what is analog signal? So when our not analogy analog, maybe like this. No, no, no. So mine is correct.
Yes.
It is showing brown. Okay. What is a modem? It modulate our digital signal. Like I said, a LAN connection. You have your own, router switches are there. All the signals we are transferring from one PC to another PC through switches or routers, whatever it is a digital based signal only. It is a weak signal, not transferable for a very long distance. What is your modem will do? Modem transfer your data for a long distance purpose. It will convert your digital signal will be converted into analog signal and forward to the ISP provider and next forward kind of stuff on it. And you receive an analog signal. The modulate, the modem will again regenerate the digital signal. So what is the purpose of converting into analog signal and send? Because analog signals can able to transfer for a very long distances. Guys, just it's I'm not criticizing anything. So just I'm telling if points or because of I know things, right? You know, we have a electricity which is generated from different places, right? One is windmills, and another one is the base, like a AC means alternate current. DC current, alternate current is battery and main power supply kind of stuff, right? So we are getting AC from windmills. The hydro power plants are there, like a big turbines, right? A riverside, they think. And thermal electricity. So like burning a coal and boil the water, so run the turbine, so then you will get a electricity. Another one is nuclear power we are getting. Okay, but what is the safest one for electricity is a solar power, right? But why solar power is not implemented in the entire our country or any other country? Very small or very another countries, okay, that is the solar powers are there. Even we don't know about other places. Like still we have a solar power, but 100% solar with the replacement of all these energy resources, we are not doing it. Why? Because of solar generate DC power supply. Okay, you can put a solar panels under the sun and connect them into directly battery is a DC. You cannot transfer the DC supply through the power lines for a very long distance, not work. But AC is alternate. It is always like a sine wave type, like this. It looks like it is this is a DC. Okay, so this is the one of the reason. So analog signals, um, not binary, it is a digital formation of signals mixing with high frequency kind of stuff. This is one point. Yeah. Next one is important. Modem connects connects to internet, means ISP provider. It connects to ISP provider, not exactly internet. Actually, it connects to ISP provider. Through ISP provider, you are getting internet. Okay, modem connects to ISP. Better is ISP. So again, I'm giving two statements separately because you are connecting to ISP, so then you are getting internet. So what will happens here? You have a modem. Okay, so here look at here. I have a diagram at bottom of this one like this is. See, this is a modem connects to ISP. When it is connecting, what it is telling, your username, your password, your ID, some ID will be there, no? So user ID kind of stuff like that. It will forward it. The ISP provider verify your information. What is your connection information? You paid a bill or not? All these things will be verified. Then what it will do once it is verified? So it will give a connection to you. Internet connection will be established. So up to modem, you'll get a internet. Up to modem, you're getting public connection, internet you are getting. Understand guys what is the use of this modem? It connects you to internet.
Yes.
Okay, like this. Next, yeah, where are we? Here only. So that is the main important point of your modem is modulator and demodulator. Modem connects you to ISP, so then you are getting internet. Okay, so I've written both the statements, so then you have to split them, make it as a one. So modem make you connect to the ISP so that you are connecting to internet. Okay, so modem makes you connect, make internet connection. So if you are not getting internet, so there is another problem with the modem. Okay, so modem works with the WAN protocols also. Modem works with the WAN protocols also, right? So this is a small part about a modem, guys. So nowadays, so that is why I'm putting a point. Nowadays, Wi-Fi routers, some, not all, some Wi-Fi routers or some routers built-in modems are there. For example, you're taken a N300 model modem or AC750 model. Like you got a some Wi-Fi router. We are looking at a your Wi-Fi router. Okay. So what we are doing it is it's a built-in Wi-Fi router is there. So I am going again this part. Look at here. This is a separate modem or a mixed modem. So this modem again combined with the routing means this side is make you to connect ISP. Once connection is established, so your router take that IP address, route that information to your LAN connection. Okay, this is a single unit. This is a single unit. This is the single unit. So make you to connect. So ISP first through modem part. It once it's a connection is established, you are getting internet to your router, like your Wi-Fi router or your router. So you got some outside WAN connectivity. So you establish a you got a WAN connectivity. This WAN connectivity routing to LAN by router part of this one. By router part of this one. That's why I use this diagram easy to explain. Yes, this part is very important. Guys, already I send a link that is hub switch router modem and there is a wireless access point is also there. So go to that wireless access point Wi-Fi's. So what is their functionality? You will get this picture also. Okay, find it. So I didn't watch that one. So I watched so many years back, but still it is better to know it. Okay, so this is the your Wi-Fi router related information means Wi-Fi router or first router. What we are purchasing router in our premises is a combination of router functionality. What is router functionality? intercommunication like this. So two different networks, it may communicate between two different networks. Internetworking router. Modem make you to connect your ISP, so then you are getting internet. So this public network will be connected to your private to public communication by your router only. Okay, so this is the second part. Third part, wireless access point. Look at here. This is wireless access point. I given a list of devices. Find out what is the wireless access point. So in my organization, I have a two type of devices: wide connecting devices, wireless devices also there. For example, laptops are wireless, wide and wireless. Mobile purely wireless. Tablets purely wireless, right? So for example, my wi-fi printer purely wi-fi, that is okay. Some network printers are there, they have a network connectivity. Normal desktops are a pure network based wide connection. So what I have to, I have take a switch or a multiple switches for a wide connectivity. For wireless connectivity, I use a device called a wireless access point. Access point AP. AP means access point, to make a device to connect together like a switch. We can able to connect together using access point. But what I'm saying it is a wireless access point. Wireless means to connect wireless devices. We use wireless access point. What it is? To connect wireless devices, we use wireless access point. Here it is like a mobile phone, laptops, desktops, okay, wireless devices. Yes, right? Now, again, we'll come back. Nowadays, what we are getting, Wi-Fi routers. The Wi-Fi routers, what we are using is a this entire combination. What is entire combination? Wi-Fi router, right? Wi-Fi router, built-in modem for connecting WAN connectivity purpose, mainly to connect ISP. So then we are getting internet. So this part is WAN connectivity part. Another is LAN connectivity part. This is a LAN connectivity. This is WAN connectivity. Okay. This is wireless LAN connectivity. So wireless LAN connectivity. Understand? WAN connectivity, wide area network, outside internet connection. LAN, local private connection. Wireless connection, wireless LAN connection. Wirelessly are connecting. Okay. So our Wi-Fi routers nowadays, what we are using is, it contains a built-in modem to connect to ISP and establish WAN connectivity. So then we are getting internet. This is the router. The router route the network between WAN and LAN, LAN and WAN. So we are LAN is different network, WAN is different type of network. So WAN is different network logically, and WAN is different like WAN network. So it interconnects between LAN and WAN networks. It make a communication between this network and this network. That is a function of router. Plus this router also having a wireless. So you can connect wide network, wireless network in the LAN, and also you can connect it to WAN connectivity. So this is a what the devices we are using nowadays, and their functionalities. Yeah, something it is there. I removed it. Okay, so okay guys, up to here the devices what we are discussed. This is the switch, router, modem, of course, hub, wireless access point. I just orally I told what is wireless access point. So one more point I want to add here. It is not a device. It is a terminology. What is default gateway. What is default gateway? Look at here, guys. I'm going to take different colors. Okay, for you. So this is a blue color, green color. All colors are used. I think this color is not used. Red color. Red is better. This is also better. Okay. So look at here. This is an explanation is happened here. So that's why it is these arrow marks are there. Look at here. APC want to communicate B. APC want to communicate BPC. So this is the packet traveling. A send a packet to B. Sorry, switch to B. Okay. A to B communication. A send a packet to switch to B connection. Is there any involvement of router is there? Router is not useful, right? Here in this one, I'm not using the router. I am directly using switch to communication between A to B. Understand, guys? Communicate between A to B, I am using a switch, not router here in this scenario. For example, this CPC want to access something like a google.com. How packet will send? Packet sent to the switch to the router. So this is LAN connectivity. This is LAN connectivity. So switch to the router. Now router is forward the packet and reach the ISP finally. ISP to some routers and finally reach the google.com. Again, I want to reach the google.com. How I send a packet? Switch to the router. Now it will stop at here. We are giving a pause here, guys. Look at here. When I want to communicate from C to B, we don't require router. Or A to B, we don't require a router. Or A to this mobile phone, we don't require this router. Or maybe this laptop to this PC, we don't require a router because it is a entirely in the LAN connectivity, LAN network only, private network only. But when you want to communicate outside of your network, you have to communicate through router only. Whenever you want to communicate outside of your network, you have to communicate through router only. So when you are entering to the router in your LAN interface, when you are entering to the router, this router's interface is called a default gateway. The router's interface is called a default gateway. Okay. So again, I'm telling guys, look at. So when you are communicating within the network, within the local network, so you don't need to use routers or default gateways. But when you are communicating outside of your network, when you are communicating outside of your network, compulsory you have to pass the packet through router only because router is a interconnecting device. It connects different networks. It forward your packets to the next level, right? So in that cases, you have to passes your packet through router. So that router interface we call it as a default gateway. Once again, default gateway now does not mean it is a router IP address. Okay, default gateway can be anything, but in this scenario, router generally it is a router IP address, router LAN IP address. Router have two IP addresses. LAN side IP address is there, WAN side IP address is there. So we are in the LAN, we are communicating to the router, we are sending packet to the router to the LAN interface only. So that is your default gateway. Okay. So this is what is your default gateway part. So that's why this diagram is very useful for understanding things. So these are our topologies. Actually, this picture must be put a before topology part. Okay, so this is the modem. Okay, here I given some more things like a modem, firewall kind of stuff. So router, this not happens here, right? I will write here. Router acts like default gateway. I can write this thing in a router side, but what happened because of the so many lines, you think it is less priority, but this is a highly priority thing. So router acts like a default gateway. So router's IP address is default gateway IP address. Never say like guys. What is a default gateway is a IP address. Don't say like the default gateway is a whenever you are communicating outside of your network. Okay, when whenever you are communicating outside of your network, whenever you are communicating outside of your network, okay, you have to you have to send. I'm telling in a normal story wise, that's why I'm writing you have to whenever kind of stuff. So normally we have to remove that those things. You have to send packet through default gateway only. Okay, default gateway. For example guys, you are sitting in a one room. We are all sitting in a simple room like a in a room we are all in the same room. Okay, so this is a big room. Okay, people are sitting here, right? People are there. We are all in the same room. Whenever you want to communicate from here to here, we don't require this door. For example, this is the default gateway to go outside. This is the default gate to way to the go outside. So you want to communicate from here to here, we don't require this gateway. You want to communicate from here to here, don't require this gateway. You want to communicate from here to here, we don't require this gateway. Means within the local communication, we don't require any gateways. But here, someone is sitting here. Okay, someone came. Okay, so you want to communicate from here to here. How to do it? Compulsory you have to go through the gateway only. Compulsory you have to go through gateway only. Like that, whenever you are want to communicate outside of your network, you should go through you have to go through gateway only. The address of this gateway is our default gateway IP address. Default gateway IP address. Okay, so whenever we want to communicate, whenever a system is communicating outside of the network, whenever it is communicating outside of its network, so compulsory whenever you are I said whenever a system is communicating to outside of its network, so you have to pass this through default gateway. The default gateway IP address you have to mention in the network. When you check the IP address, check IP address separate mask default gateway. Generally default gateway is a router's IP address. Generally default gateway IP address is your router IP address. So these are the point guys. I'm not written or written. You can check it once again. So I told about the devices and default gateway, which is very important thing. So there is a some more things are there like what is VPN server. what is VPN, what is firewall, what is proxy, access points. I told wireless access point. I told Wi-Fi routers. I told so VPN, firewall, proxy kind of stuff. So we'll see it after. Just take a 2 minutes break, guys. Just 5 minutes break. I'll finish up today.